Okay, so first, before I forget, there's a quiz tomorrow. And it's just on the stuff that we did last week. So that includes surface area of prisms. Surface area of cylinders and square pyramids. Okay, that's it. That's all the tests on. So yesterday you had some homework. Yeah, question.
I was going to ask, well, the homework yesterday was something you already did.
Yeah.
And but there was another homework that said it was for yesterday on Delta Net. It said Monday on it. Were we supposed to do that?
Surface area of pyramids?
Yeah, but we did that last week.
No, last week it was surface area of square pyramids.
But huh? I know, I said I did that.
Yeah, I'm not sure. Any other questions then? You good?
I'm checking.
Okay. Well, just let me know, okay? All right. So yesterday you had that homework on surface area of pyramids. Any questions on that stuff then? Pretty straightforward, right? Okay, good. So today we're going to talk about surface area of a cylinder. Not a cylinder, a cone rather. So surface area of a cone.
Oh, that's square pyramid.
You good?
Yeah.
Okay.
Yeah.
So surface area of cones. So a cone is basically like a pyramid, except the base is circular instead of polygon. It's the only difference. Okay, so this base is just circular. And all the cross sections are circles as well. Okay, that's what a cone is. You knew that already, I'm sure. All right, so I'll tell you the surface area formula, and then I'll explain why it is what it is. Okay, so the surface area for any cone the surface area is pi r squared, which is the bottom, let's see, the base, the circular base, that makes sense, right? Pi r squared plus pi r L. And remember, L is the slant height, just like it was with a pyramid. So L is like this distance here. And R is the radius of the base. That's all. Okay? So it's very reasonable to ask why this is what it is, because it's not obvious at all. It's kind of obvious for a pyramid why the formula is what it is. You're just adding up triangles and polynomial. And it's pretty obvious for a prism why the formula is what it is. You're just adding up two polynomials and a bunch of rectangles. So up until this point, the formulas have been pretty straightforward. This one's a little bit mysterious. So let's talk about it for a second. So why it is. So remember, first of all, for a pyramid, the surface area is the area of the base plus the lateral area. Remember, that's just the word that we have for sidewalls. So the area of the base, that depends on what shape the base has, but it's usually a regular polygon of some sort, so you just add up a bunch of triangles. The lateral area, you can consider this to be the following formula. It's really n times 1/2 s times L. Now that might look a little bit strange, but in this formula, n is the number of sides on the base so if it happens to be a hexagonal pyramid, then n would be 6. S is the length of a side on the base. Length of a side on the base. And L is the slant height. Okay, so let's make sure that this formula makes sense. Like if we have a hexagonal pyramid, for example, the hexagonal pyramid would look like this, right? In this case, n equals 6. That's the number of sides that there are in the base, right? This distance right here is S, and the perpendicular height of the sidewall, this is L. So doesn't this formula make sense? It's just 6 times 1/2 S times L. Each side wall of the pyramid has an area of 1/2 S times L, and there's 6 of them. So we're just multiplying by 6. Does everybody understand this formula? Makes perfect sense, right? So we can actually like change the formula slightly without changing it at all. And that the way we can do that is just rearrange the things that we're multiplying together. Multiplication is a commutative operation, which means it doesn't matter if I multiply n first, or if the n goes in the back, or if the n goes somewhere in the middle. It doesn't matter, right? Because it's multiplication. So this is really the same thing as the area of the base plus 1/2 n times S times L. That's the same. Don't you agree? N times 1/2 SL is the same thing as 1/2 and SL. Multiplication is commutative. The reason why I'm rearranging it like this is because n times S, you just think about what that is. It's just the perimeter of the base, right? There's like in this case, there's 6 sides of length S. So the perimeter of the base would be 6S, right? But in general, no matter what the shape of the base is, it's going to be n times S. N is the number of sides of the base, and S is the length of a side of the base. So this all ends up being the perimeter of the base. So the reason why that's important is to rearrange it so that you can see that that's the perimeter of the base is when you talk about cones are like special types of pyramids. And if you think of the formula as being the same as this, then the formula is really obvious as to what it is. Like if I think of a cone, or a cone, which is really a pyramid with circular base, it makes sense that the surface area should be the same. It's the area of the base plus 1/2 the perimeter of the base times L. It's the same formula as the formula for any pyramid. But when it comes time to actually figuring out what these things are, since it's a circular base, we know the formula already for every one. The area of a base is just pi r squared. What's the perimeter of the base if it's a circle? What's the word we have for that? Circumference, right? And the formula is 2 pi r, right? This is just 2 pi r times L. But the half and the 2, they just cancel each other out, and you get pi r L. And look up at the very beginning, what we started talking about, we had pi r L. And that's where this formula comes from. It's just half the circumference times L. So this ends up being pi r squared plus pi r L. Pi r squared is the area of the bottom. Pi r L is the area of the sidewalls of the cylinder. Okay? That's what our goal was, is to get to that formula. Okay, so if you know all the relevant dimensions of the cone, this is super easy. You just apply the formula. So like, for example, we had a cone that was shaped like this. And let's say we knew that the base radius was 5 inches. And the slant height was 6 inches. Then the surface area would just be pi r squared, so pi times 5 squared plus pi r L, pi times 5 times 6. That's it. This is 25 pi plus 35. So the answer would be 55 pi. And the units are still square inches. Now, the ways that they would likely try and confuse you are the same ways that they would likely try and confuse you when it comes to cylinders or something like that. They might give you the diameter of the cone. Or they might, instead of giving you the slant height, they might give you the actual perpendicular height. So don't be fooled by that stuff. Like, for example, if I gave you something like this and I said, triangle. So let's say you have this cone like this. And maybe this is like 6 feet across and 4 feet tall. So you have to do a little bit of work and make sure you have all the information that you need, which is the radius and the slant height. The radius, that's easy, it's just half the diameter, so this is going to be 3 feet. How can you get the slant height, this distance? You know that the altitude is 4 feet. Exactly, the same trick that we did for a pyramid. You're going to draw a triangle like this, and it happens to be a right triangle, right? This is 4, this is 3, and that's L. So what does L have to be in this case? 5. This is a 3, 4, 5 triangle. Now you can do the formula. So the surface area here would be pi r squared, pi times 3 squared, plus pi r L, pi times 3 times 5. So this is 9 pi plus 15 pi. The answer is 24 pi square feet. So this formula, in my opinion, is actually a lot easier to use than the pyramid formula. Remember all that work we had to do for pyramids? You had to do the formula for a regular polygon, which usually involved remembering what special triangles look like, and then doing like 6 times 1/2 base times height, and then the sidewalls, which are 6 times 1/2 base times a different height. So it was like way more work. This formula is actually really simple to use. Okay. The other way that they might try and confuse you, just like when we were talking about cylinders or any of these figures so far, is they might, instead of asking you for the surface area, they might just ask you for the lateral area, which is just the sidewalls. That's just the pi RL part of this. Okay, so just be careful, read the question, make sure you're answering the question that's being asked. If they're asking you for the surface area, pi r squared plus pi RL. If they're asking you for the lateral area, it's just pi RL. And make sure you're using R and not the diameter. Any questions? Straightforward. All right. So the homework is actually on IXL, and it's called, because they don't have anything about cones on Delta Math, unfortunately, and it's just called Surface Area of Pyramids and Cones on IXL.